All right, so let's multiply by the complex conjugate, which is 8 plus 2i. It's always for the denominator that you look at this, and it's always the real number is the same, and then the imaginary part changes to the opposite. So the opposite of 8 minus 2i is 8 plus 2i. Okay, so this essentially becomes two problems. We're multiplying 10 plus 8i times 8 plus 2i for the numerator, right? So we have to multiply, distribute the 10. So 10 times 8 is 80. 10 times 2i is 16i. And then we'll distribute the 8i. So 8i times 8, that is 64i. So I'll put that under the other I term. And 8i times 2i, that's 16i squared. Anytime you write I squared, you go ahead and mark through it and change the sign to the opposite. So this is a negative 16 and an 80 that we could combine together. So 80 minus 16 is what, 64? And then we have 16 plus 64, and those are both I terms. So that is what, 80? Yeah, that makes sense. Okay. All right. So the top here is 64 plus 80i. Okay. So now we're ready to do the denominator. So 8 minus 2i times 8 plus 2i. And remember, the whole reason that we're multiplying by this complex conjugate is to get rid of the I in the denominator. So when we get this answer, we should not have an I term like we did for the top. So 8 times 8 is 64. 8 times 2i is 16i. And then we'll do the inside. Negative 2i times 8 is negative 16i. Notice those are the same, but have opposite signs. That always is the case here. Negative 2i times positive 2i is negative 4i squared. Mark out the I squared, change the sign in front. 64 plus 4, that's 68. And then remember, these become 0 because they're the opposite of each other. So the denominator is just 68. So we know that we're probably on track because we didn't have an I term in the denominator. So we're on track as far as that goes. And now we have to think about how in the world do we reduce this fraction? Well, let's see. I know that everything here, will divide by 2, right? We could think of this as 2 times 32, and this is 2 times 40, and this is 68. What, 2 times 34? Okay, so the 2's will all cancel out. Okay, so now we have 32, 40, and 34. Those are all even numbers again. So that would be 2 times 16 and 2 times 20. It gets very messy, doesn't it? And 2 times 17. And notice that all these 2's can cancel. Okay, so now we have a 17 on the bottom, and that's a prime number. Nothing multiplies to get 17. So this is as simple as it gets, which doesn't look very simple. Let's see what we have left. We have a 16 and a 20i, and we have a 17. And that is the simplified version of this problem, this division problem. All right, I hope that helps. I'll see you in the next one.